My name is Vinay. I'm a product manager on BigQuery. I primarily focus on administration, observability, monitoring, system optimization recommendations. I'm joined on the stage by Junaid from Geotab. Please welcome him with the big hand. All right. So as I was mentioning, I focus on observability, and my team's mission is to make BigQuery as easy as possible to manage so that you spend less time managing BigQuery and more time doing the tasks that create business value for your organization. And most of the folks that I speak to who are responsible for BigQuery operations have a similar set of goals, common set of goals, making sure the system is running as expected, the business folks are getting their reports on time, the data scientists, analysts are able to do their work without any issues, and if there are issues, you're able to sort of troubleshoot them quickly and get it back up and running quickly, right? And that's why at BigQuery, in our team, we're super motivated to provide you with a really strong observability stack, all the way from a robust data layer, all the way to native dashboards in the product itself, right? And different customers approach optimizing operations in a different way. And today we have Junaid, who's going to share with us how Geotab has approached optimizing operations, BigQuery operations at their organization, and with great results. And so he's going to share, tell us about their journey and the valuable learnings that they've gained on the way. So Junaid, without further ado, here you go.
Awesome, thank you very much. Okay, sorry. Thank you very much. Thank you very much, Vinay. Good morning, everyone. Great crowd, what a event, Google team. Great job with that. My name is Junaid, and I am AVP for Enterprise Data Office. Enterprise Data Office, fancy term. So basically, it's data operations, data observability, data enablement, and ML ops under one umbrella. That's what I look after day to day. I want to start my slide or my presentation from some reflection of last year's Next. I was in a similar session, and I was sitting somewhere at the end over there, as I am a backbencher from day one. And I was thinking, what can we do in Geotab to optimize our cost and the use of BigQuery in Geotab? So that's the motivation I took from the session last year. And now I'll be talking about the work that we did in just like last 9 months on optimizing BigQuery in Geotab, not just the cost, but also how it's used across the organization. The agenda today is basically divided into 2 sections. I'll talk about what Geotab is so that you guys can understand where I'm coming from. And then the later half of the presentation is divided in 3 sections. I'll talk about past, where I'll talk about our challenges, our problems, and I'm sure most of you who are using BigQuery can relate to it. And then I'll talk about a time which I label as present, where we actually invested on BigQuery operations as a dedicated initiative. And we were able to get very good results that I'll share with you guys. And then last but not least, future, I'll invite Vinay to talk about what's coming in BigQuery as a native capability that you can use to monitor and manage BigQuery as a critical tool in your organization. Before moving to meat and potatoes, I'd like to thank you, my team, who's behind all the great work that I'm presenting today. So this is the great team that is behind everything, and what a beautiful picture. What is Geotab? This is probably the question that you might be thinking right now. Geotab is a global leader in vehicle connected space. That includes vehicle asset tracking, fleet tracking, and the hardware on the left side is plugged in a vehicle which collect high fidelity data from a vehicle ranging from 1 Hertz to 100 Hertz. And the signals that I'm talking about range from your oil temperature, your car's cranking voltage, location, accelerometer, and there are thousands of signals that we collect in real time. Now imagine the scale of this data if we have 4 million connected vehicles. So we collect this type of data across 4 million connected vehicles. And that amounts to roughly 75 billion data points per day. a quick exercise that we did, that our visualization team did. So we plotted all the road segments in North America and highlighted the road segment where we have seen a Geotab vehicle. So the map on the right is basically where we have seen a Geotab vehicle. So that's the amount of data that we work in, day out. Now, talking about data culture at Geotab, it's important to understand the space that we operate in day in, day out, to understand the challenges that we were facing, and we are still facing with BigQuery operations and optimization. With roughly 75 billion data points, we have thousands of data pipelines that are responsible for transforming the data, massaging the data, aggregating the data for downstream user. This is one stat that actually hits the message home, which is 80% of Geotabbers have interacted with BigQuery or indirectly in the last month. 80% of the organization have touched BigQuery one way or the other. So that's how critical BigQuery is for Geotab. And that talks about data culture at Geotab as well. There are some other stats that I'll just pass on in the interest of time. Now, past. So as I said before, the slides are divided in 3 sections. Past is where I'll talk about the challenges that we're facing. And roughly, start of 2022 is when we started our dedicated squad around BigQuery operations. And it was a shared responsibility among different squads. So that's why this red line is that period when we actually started investing in BigQuery optimization. What were the challenges that we were facing? Looking back, 2021, performance issues, starting with that. 80% of our queries in Geotab were running under a default reservation. What does that mean? Which means that we cannot give different experience to different type of workloads. We cannot guarantee consistent SLOs across different type of application. 99% slot utilization during peak hours. Well, you can debate high slot utilization is good, but on the cost of increasing execution times, right? So there are variables that we have to balance as we are optimizing on slot utilization. Second part, increasing cost. You know that if you don't control BigQuery as an environment, the cost stacks up every day. If you're not cleaning your storage, the cost stacks up for that every day. So that's what we were noting. Continuously, our cost for BigQuery was increasing every day. And there was no line in sight where we see it coming down without any dedicated effort. And then the third part, which is basically, for some of the services, we were hitting the quota limits, which means that the system was no longer usable for the applications. This is a message that I got in one of our chat groups where someone was saying that they're getting concurrency error from GBQ. Right? So this is the situation we were in. And then also some other basic challenges that every organization face: data management challenges, lack of accountability, insufficient tooling for monitoring and alerting on different BigQuery assets. Now moving to present. Present is a time period where we actually started investing in dedicated BigQuery operations. There was a dedicated squad with mandate to optimize our cost and experience for BigQuery as a critical tool in the organization. What was our approach to optimization? This is something that we have developed over time. If I say that this is something that we adopted on day one, it's not true, because this is all based on experiences, and I just want to share it with you as an audience that so you guys can take back to your organization and actually start your optimization journey. Start with analysis of the environment. Try to understand how BigQuery is being used in your organization. If you don't understand the scope of it, you cannot do anything about it. So try to understand how BigQuery is being used in your organization. And then there are many good tools that you can use. You can actually look at your billing data. You can actually look at information schemas to understand how it's being used across the organization. So there's no shortage of data that can be used to analyze the usage. Once you understand the usage, align with stakeholders on expected behavior. As an organization, there should be an alignment across the board how BigQuery should be used in the organization, and what are the different SLOs or SLAs that different teams have to meet. Once that is determined, put appropriate monitoring on top of it. Right? You need visibility. You need full visibility into what's going on with BigQuery as a tool, because if it's critical for your business, it's important for you to have a full visibility into it as well. After that, alerting. Alerting is very important, because if you're not on top of BigQuery operations and you're not alerting proactively, there is a huge downstream impact. Customers can see the impact. There can be increased cost. There could be so many different factors that you have to pay for. Like, for example, autoscaler. If you don't have a full visibility into how different systems in the organization are using autoscaler, and you don't have alerting set up on it, by the time you know about something, you are already incurred a cost for that. So stay on top of your cost through different alerting mechanisms. And then enforcement. Now, there are two different types of techniques that we adopted for enforcement. One was, as a best practice, we created a lot of best practice documents, like this is how you're supposed to use BigQuery, don't use it for transactional workloads, et cetera, et cetera. But at the same time, we started enforcing some of these policies as a technical solution as well. We started canceling some jobs that were coming from specific type of BI platforms instead of just relying on BigQuery default timeout, which I'll talk later as well. So this is the framework that we adopted. Now, key things to remember, lesson learned in the last 2 years. All efforts should be grounded in business objectives and goals. That's the single thing that will help you align all the stakeholders. Second thing, put your action-oriented team members on this. Third thing that is very, very important, Pareto principle is you will see this principle applicable every day. Once you analyze the usage across your organization, you will see 80 or 90% of the usage is coming from 10 to 20% of the application. So focus on the areas where we're causing the most pain. And fourth point, show impact early on. Every organization has to make a business case for any new investment. Try to show the impact of this initiative early on. And that is only possible if you literally apply the Pareto principle. Key ingredients that we use: have a solid data architecture. When I say data architecture, what we did in Geotab is that we introduced a concept of functional area. A functional area can be a system, can be for a system or application. A functional area can be for a department or a user group. So we separated out all the use cases by functional areas, and then within functional areas, we created subsequent data zones. Like, an application can have a dedicated functional area, and then within that functional area, they can have raw, test, or production or staging data zone. And all these are linked back to GCP projects. Now, what it did is it enabled us to make people accountable. It enabled us to establish cost center. It enabled us to do appropriate reporting and alerting to the right stakeholders. So this is a very important piece that we did very early on, and it helped a lot throughout the journey. Second thing, not very difficult, but very important. Centralize BigQuery metadata in one place so that it's easily consumable across the organization. People who use BigQuery metadata or information schemas today, they know that there is a permission structure that goes on top of it, and it makes it sometimes very difficult to leverage it or open it to everyone in the organization. So centralize BigQuery metadata if possible. Now, let's talk about the practical application of this framework. That's where I'll talk about the actual actions that we took. Sorry. So I've divided the content in 3 different sections, starting from ingestion. So this is basically, these are the 3 major cost drivers for us in BigQuery here at Geotab. So starting from ingestion, what we found out was that there was no standard practice of using different ingestion APIs across the board. That's why we were seeing consistent rise in ingestion cost. And then also the other thing that we noticed is that downstream users are using APIs of their choice without making a determination if they actually need batch or streaming ingestion. So there was no determination that was being made at the time of choice of technology. So we started with taking inventory across the board. That was our first step. We took inventory of every application that was pushing data to GBQ. We worked with the product manager. We defined if they actually need batch or if they need streaming. After making that determination, we started moving workloads to their appropriate ingestion methods. Now, at Geotab, all our system data, such as Salesforce, Dynamics, all the integrations that are for our internal data consumption, they are on batch. We don't need real-time Salesforce data. We just use it to run our business. It's one-day lag, does the job. Same goes for Dynamics, same goes for other administration system, not customer-facing. Whereas if I talk about the telematics data, the data that we collect from devices, the data is data that is then later presented to our fleet manager is streaming, because we need near real-time data so that we can do different types of insights on it. So we separated out ingestion application based on their use case and need. After doing that, this is just one example. So we moved, after moving all the application to their appropriate ingestion methods, the bar chart on the bar chart on the left is basically drop in cost. So roughly on average, we are paying $600 to $800 per day for one application in ingestion cost. After making these changes that I've talked about, it dropped to around $50 or $60 per day. So literally 90% of savings after making this change within Geotab. So you can also do the same thing in your organization. Start with taking inventory. Start this conversation if you are using the appropriate ingestion methods. Even within streaming, do you need streaming write APIs or do you need storage write APIs? Right? So if you understand the differences, the cost is very different. So have this conversation in your organization. The second important piece is storage. Our second cost driver is storage, as you all understand. What we found out, developers or data scientists, they were not doing post-dev cleanups. They were creating tables. They were pushing things to production. After that, no one was doing any cleanup. The data was just stacking up. So that was one thing. Production data expiry, no consistent policy around data expiry. Data model optimization, no focus on data model optimization. Knowing GBQ is a columnar storage, how can we leverage that information and minimize our spend, optimize the workloads that are running on top of it? And the fourth point, which became relevant last year, choosing the appropriate pricing model. Right? I'll talk about the last point in detail in one of the slides, but starting with regular hygiene. So that's how we started on our storage journey. We realized very early on, so we actually, what we did was we interviewed different data stewards. Like, why you're not cleaning up your environment? Single answer that we got from them, we don't know what to clean up. We don't know what is not being used. We don't have sufficient tooling to actually do the cleanups. I'm talking about 2021 or 2022 when there was not a lot of monitoring in native BigQuery. So what we did was we created dashboards for data stewards where they can actually go in and select their function area and see which data set is not used for last 120 days, last 90 days, so that they can drive their cleanup activities. In the bottom line chart, you can see that we were roughly, when we started the major cleanup, we were at left roughly 50 petabytes. After a major cleanup that we did, based on what I explained, we saw a drop in roughly 33% savings just with one major cleanup. Now, every day is not the same day, so you can't get same type of savings every day. The other thing that we kind of promoted in the organization is we have now monthly fix-it Fridays. Every data practitioner has 2 hours to 3 hours blocked in their calendar in a month where they're supposed to go and clean up their dev environment. So the small dips that you see here, they're actually outcome of those fix-it Fridays. So we promoted a culture of hygiene. And obviously, as I said before, you can't get 33% savings every day. But 3% is not, 2% is not. And it's a culture that we are driving here. OK. Data management, in the interest of time, all standard stuff. Storage billing model. This is something that we did recently. Because as you all know, that you can now choose pricing at a data set level, right? You can choose if a data set needs to be built at a physical storage model or a logical storage model. So what we did is we actually ran a simulation for a couple of months where where the decision was made every day if a data set needs to be one or the other billing model. After running that simulation, we saw promising results. And after implementing this application in the organization, we additionally saved 8% on our storage pricing. So there is a very good resource on Google Blogs. If you search for physical versus logical storage model, it actually walks you through a step-by-step approach for running the simulation. So try running the simulation for your organization. It's literally a Google Sheet where you make decision based on what is cheaper. Very simple. So this enabled us to save additional 8%. Last bigger driver of cost, compute, slots. This is a very sensitive topic for all the BigQuery users. What are our findings? So when we did analysis on how slots are being used, or BigQuery is being used for compute in particular, we saw different types of use cases. Customer-facing applications, internal operations, BI tooling, some transactional workloads as well. Some applications were using it as a Postgres database, right? So which is obviously not right. The second thing that we identified very early on, which I talked about initially as well, that we realized that slots, we need to better organize our slots. We cannot control the experience if our slots are not better organized. So we started from a world, I'm talking about 2016, 2017, when we adopted BigQuery. We used to have one default slot pool, and everything was running in it. But as our practice grew over time, we realized that, no, we need better organization on that if we want to control experience or meet our SLOs and SLAs. Fifth point that I want to highlight, education and coaching on query optimization across the organization. There were only few individuals in our organization who had this expertise, who actually knew how to optimize a query. So we created curriculum just focused on query optimization, query tuning, that then was pushed across the organization to different data practitioners so that it's a shared responsibility, not just one or two data scientists who are expert at it. Now, how many of you can relate to this thing? This is a message that I got like 2 years ago in one of our chat group. What's wrong with this message? Is GBQ too slow for anyone today? This fundamentally wrong. This message is fundamentally wrong. This person who has posted this message probably doesn't understand how BigQuery works. It's not that the GBQ is slow for us today. It's just because we're not using it properly. We don't have proper segregation of workloads. So invest in data literacy. That was our step one. So the bottom image you see here, that's our headquarters, Oakville office, Oakville, Ontario. And we have big wall boards across the office where we have all these operational dashboards. Up there, everyone can see how a given system is doing. And additionally, what we created is we created a lot of tooling that the data practitioners can use to understand the impact of their queries, the impact of what they're doing. A very relatable example that I would like to highlight here. So there's one dashboard here, somewhere here. What it does is basically it lists down users based on their slot consumption for the last 2 hours. There you can see the table here. So one of the users saw that he was at the top of the list. He actually reached out to data ops. He's like, I don't know what else I can do. I've optimized my query. Can you guys help? So the data ops team actually helped him to further reduce the slot consumption by 60%. So the idea that I'm trying to pitch here is that everyone wants to optimize their queries. Everyone is actually interested in tuning their queries. But if you need to, as an organization, create this level of visibility, they need to know. They need to know the impact of their actions. So invest in data literacy. Second point, slot organization. I've talked about it a lot, but in the interest of time, I'll quickly go through it. We had one slot pool, which we divided by application, by user groups, and then we further segregated it by different departments and also by different applications as well. So now our reservations are associated to different projects, and those projects are linked to different type of functional areas or based on their specific use case. Implement workload-specific policies. Not every workload is the same. A query that is originated from a customer-facing application versus a query that is originated from a dashboard. Is it OK for a query from a dashboard to run for more than an hour? Not really. Like if it's a dashboard, it should run under 10 minutes, 5 minutes. That's the experience that we're expecting on dashboard. Versus if it's an analytics job, it can run for 6 hours. That's fine. So what we did is, like, because now we have control over our environment, we implemented workload-specific policies. This is one example. So now we have a policy that if a query is coming from a BI platform, the timeout is 30 minutes, not 6 hours. What it did is that, so if your job is canceled because of this timeout policy, you get an email from our system that tells you what to do, how to optimize your query. Do you need an aggregation pipeline for this dashboard to prep up the data? So this is important. Now, last point before I pass over to Vinay to talk about what's coming next in BigQuery natively, why it matters. I've tried to show you guys the results of what we are doing so that it's more relatable. Why it matters. So the blue line here is basically our device count over time. It's around 4 million right now. And the red line is the slots per device. If I compare Geotab 2024 compared to 2022, we have almost double the number of data initiatives we had before, but we're using 25% less slots per device today. How is that possible? It's possible because of what I explained, what I talked. And there's a lot of hard work that goes behind it. And when we started on this journey, most of the tooling was not available in BigQuery natively. But today, a lot of the new monitoring tooling is available in GBQ, and most of it is coming in the next couple of months or a couple of years. And that's where I'd like to invite Vinay to talk about the future roadmap of BigQuery on operational observability. Thank you.
No, thank you, Junaid, for sharing these valuable insights from all of the amazing work that you and your team have done at Geotab. I certainly found it super insightful and useful, and lots of really good nuggets in there. Hopefully, towards the end of the session, we will have some time for Q&A, and if you don't, I and Junaid will be available outside as well if you want to pick Junaid's brain and have more questions, or if you have questions for me. So, as I mentioned at the top of the session, we at BigQuery are super motivated to provide you with a really robust stack for observability so that you can get a lot of the value out of the box, or you can actually build sophisticated tooling just like what Junaid and team have done as well. So I'd like to take this opportunity to sort of walk you through some of the recent launches that we've done and some exciting work that we are sort of currently invested in. So the first thing I want to sort of talk about is the suite of dashboards that we've launched over the year or so to natively in BigQuery monitoring, right? First of those is resource monitoring or resource charts that we launched about a year or so ago, where you can track key metrics like slot usage, byte scans, shuffle usage, concurrency. With a rich set of filters, you can slide and dice, and sort of the go-to tool for troubleshooting what's going on in the system, right? And I'm super delighted to see really active usage on this tool over the last year since we've launched, right? And so this is sort of the foundation. And sometime late last year, we got a new tool called Jobs Explorer to public preview. And this tool gives you a organization-wide view of all of the queries that are running or have run in your organization with a rich set of filters and a bunch of data, as in who ran the query, how many slots did it consume, how long did it run, which project did it run in, right? And you can sort of zoom down into different reservations or projects and identify the most expensive queries. You can dig into a specific query and look at more details of a particular query. And if there's runaway queries, you can kill the query directly from the tool as well. Right? So super powerful tool, and I'm seeing some good usage in the tool, so encourage you to sort of make full use of the tool as well. And we expect this to go to GA in the next couple of months. And last but not least, we also have an operational health dashboard that went into public preview late last year, which is a single pane of glass view of all of the key metrics across the organization in real time, like by region, by reservation, top errors in the organization, top queries, and you can sort of zoom into a specific region or a specific reservation and see a detailed view of the key metrics in that specific region or reservation, or even edition that we've recently added. So all of these tools are built on the foundation is information schema data, so where we continuously invest and to expand it, and BigQuery has a crazy speed of launching new features, and as we're launching new features, we continue to add and expand to this information schema base, right? So those are dashboards, and a lot of both of these, both the Jobs Explorer as well as the Operational Health Dashboard, will go GA in the next couple of months. So we talked about system observability. Then we also have a tool that went GA sometime mid last year, which focuses on a specific queries observability, right? Because the system essentially is made up of all the queries that run in the system. And it's the query execution graph, which gives you a graphical view of the query's plan and shows you bottlenecks in the query and detailed metrics for each of the steps, right? So that you can have an easy way to sort of understand what's going on in the query, troubleshoot the query, understand the query. And we've also added a bunch of insights that go along with this tool, right? So does the query have a high cardinality join that's slowing it down? Or is there data skew in the query? Or like if the query was running slower today, because I think the thing that Junaid pointed out, is GPQ running slower today? Like somebody's saying, my query is running slower today. So it could be like the data scale changed. It's processing a lot more data today. Or was there slot contention in the reservation where the query was running? So all of these insights are also available as part of the tool. We continue to invest in this tool to make it more easy to use, because looking at a graphical visualization, the plan is not the easiest thing to sort of jump into. So we're investing in making it more easy to use and also adding more insights for easier troubleshooting, so that this becomes the first stop for you to understand and troubleshoot a query, right? So last year was a big year for BigQuery. We launched Editions, which is one of our biggest launches in many years. And we introduced multiple editions and amazing autoscale functionality. And to make it easy to make some capacity decisions around this new model, we introduced 2 new recommenders to go along with this. The first is a edition capacity planner, which looks at your organization slot usage or edition slot usage and computes the most cost optimal settings for the edition. And recently we also launched a recommendation at a reservation level, where the recommendation pipeline looks at the usage in the reservation and sees if it's undersized and the queries are being negatively impacted by performance. And if it detects that pattern, then it spits out a recommendation with an optimal size for the reservation. So both of these are in public preview and will go GA soon. So in addition to capacity recommenders, we also launched a couple of system optimization recommendations. One is a partitioning and clustering recommender, and the other is a materialized views recommender. And both of these recommenders look at the tables in your projects and the traffic that these tables are getting and the different queries and what the query patterns are, and identifies opportunities where you could improve the performance of your queries or optimize cost by introducing a partition or a cluster or a materialized view into the system. And both of these are in preview again and should be going to GA in the next couple of months. So a lot of stuff coming. So in public previews, heading towards GA. So super excited about giving it all to you soon. Right? So in addition to all of those features, there's a bunch of other stuff that the team's actively working on. Right? And a couple of highlights from the backlog. One is cost attribution. Ever since we launched editions, this has been sort of top of mind for a lot of customers. A lot of customers have reached out to me saying, we need better cost attribution. I want to know what's the cost at a particular project level. And we have a private preview that's out there, and a bunch of customers are using it, and giving us some great feedback. So we're actively sort of iterating on top of it to sort of take it to, sort of make it better and take it to GA at some point. And then we have operational alerts, and I think what Junaid was referring to, all of these dashboards and data that you have, one of the key pieces that needs to sit on top is an easy way to sort of alert on a lot of these metrics, right? And it could be just key metrics or any pattern that you could come up with. So we are actively working on SQL query-based alerts where you could bring your own query, you attach it to a policy, and you'll be alerted to any pattern. And like the rest of GCP, our team is actively thinking about how to bring the power of Gen AI to sort of make troubleshooting and monitoring and optimizing more easy, right? So a lot of ideas at play here, and definitely you'll hear more in the next couple of months or next couple of quarters in this, what we're going to do in this area.